All right, my friends, and welcome back to more improper integrals. So today we're going to talk about vertical asymptotes in this video. And what we're going to be doing here is basically if you have an asymptote at a bound or in the middle of your bounds. And when we have a vertical asymptote, typically that's going to happen when you have it divided by 0, or occasionally you have a natural log of 0. Those are kind of the main places where we're going to have a vertical asymptote. So what I mean by this is, like, for example, if we have the integral 0 to 3 of 1 over x, like, this has a problem, right? Because what happens is this function 1 over x is undefined at x equals 0. And that's the lower bound. So you're trying to integrate a function that's undefined at 0. So for example, let's actually do this problem. And when we have this, so integral 0 to 3 of 1 over x dx, what you're trying to find graphically is if you were to graph the function y equals 1 over x, it looks like this. And you're just saying, like, let's go to 0 to 3. So let's find this area in here. And you can see it has a vertical asymptote at 0. So it goes infinitely high. But the question is, what is that area? And just like before, sometimes it's going to exist and sometimes it's going to be infinite. Okay, and what I want to point out, this is the same strategy. So what we're going to be doing is the same as the last video. We're going to write it as a limit and then integrate. And then we're going to take the limit. Everything else is going to be the same. So what we're going to see is when you see this is undefined at x equals 0. So again, I'm going to write that as a limit. So instead of going to 0, I'm going to go to some a. So I'm going to find the area from a to 3 and say, what is the area from a to 3 as that a gets infinitely close to the x-axis? That's what we're doing, is what happens when I find that area from a to 3 as that a just goes to 0. So we're saying, what is the limit as a goes to 0 of integral a to 3 of 1 over x? Okay. Now again, this is the same thing as the last video. We're going to go ahead and we're going to take the integral, then we're going to do the limit. And that's what they're looking for on the AP test. They want you to understand that this is a limit and you're writing it out as a limit. So you're writing this out as the limit a goes to infinity. Of course, we know how to integrate that. That's ln of x going from a to 3. So this becomes the limit as a goes to 0 of the natural log of 3 minus the natural log of 0. Now, So this becomes ln of 3 minus ln of 0. And as you probably remember, or hopefully should remember, ln of 0 is undefined. So this is an example of a divergent integral, basically meaning that the area is infinite. Okay. So let's do another one, which, spoiler alert, actually will exist. So let's say we take the integral from 1 to 2 of 2 over the cube root of x minus 1 dx. Now, same trick as in the last video. We want to do the u sub before we write it as a limit, just to make our lives easier. And you might look at this and just say, hey, right away, I see there's an issue at 1. If I plug in 1, I get a 0 on the bottom of this. But I want to go ahead and do the u sub first. I have this in parentheses. So my u is x minus 1. The derivative of that, of course, is just dx. So if I change my bounds here, I have 1 to 2. So 1 minus 1 is 0. 2 minus 1 is 1. Okay, so this becomes integral 0 to 1. Let's see, dx, everything works. So that's just a 2u to the negative 1/3 du. Okay, cool. So let's go ahead and do this integral then. So now we recognize, this is 2 over the cube root of u. So you look at this and you're just saying, like, okay, this is going to be undefined whenever the bottom denominator equals 0. So whenever u equals 0. Okay, and we see that that's our bound. So that's the part that we need to go ahead and write as a limit. So I need to write this as the limit as a goes to 0 of a to 1 of 2u to the negative 1/3. Now, without the limit, right, this is a very simple integral. You guys know how to do this. You guys could do this months ago. So this is just going to become 2, and then that'll be, okay, so raised by 1. So u to the positive 2/3 balance in front with a 3/2. The 2's cancel, going from a to 1. So this just becomes a limit a goes to 0 of 3u to the 2/3 going from a to 1. So that becomes a limit a goes to 0 of 3 times 1 to the 2/3 minus a to the 2/3. Okay, so 3, sorry. So when I plug that in, 1 to any power, of course, is just 1. So this is 3 times 1 minus, okay, and what is 0 to the 2/3? Well, that's the cube root of 0 squared. And I'm pretty sure the cube root of 0 is 0. So that's just 3 times 1 minus 3 times 0. So this just works out to be 3. Okay, so we have a vertical asymptote there, but the area is actually 3. So that works out pretty nicely. Again, sometimes they're going to be 0. Sometimes it's going to be like this case, like that one was divergent. This one we can also say the integral converges to 3. So the area approaches 3 as you take that limit. Okay, and the only other thing I wanted to say is what happens if you have an issue in the middle. So what if you have the integral from -2 to 2 of 1 over x to the 4th power? Okay, so whenever you see this, and this is something like I've been really careful about all year, but I know you guys have not been, even though like you might have seen this an issue. But whenever you have a definite integral, with a fraction, you need to see if the bottom equals 0 between the bounds. So what I will always do, and I've been doing this in my head all year, is just set the bottom equal to 0. Set x to the 4 equals 0. So that happens at x equals 0. So what you need to do in this situation, if you see it's at 0, then you need to split this up, right? So I need to split this up at x equals 0. And this is true anytime you're integrating a fraction. If you have a 0 on the bottom, you need to split that up as one of your bounds. So turn this into the integral from -2 to 0 of 1 over x to the 4 plus the integral from 0 to 2 of 1 over x to the 4. And then what you're going to do at this point is you're just going to go ahead now is do both integrals and then add the answers. But I'll tell you right now, just if one of them diverges, they both do. So if you get that one of the areas is infinite, you don't need to worry about it. The whole thing's got to be infinite as well. It'll always be the case that if one's infinite, the other is as well. So it's not a problem at all. Okay, so let's take a look at what happens here. So on the first video, or the first one we can see, we know the issue is at 0. So this becomes a limit a goes to 0 of integral -2 to a of x to the -4. So this becomes x to the -3 over -3, so -1/3 in front. Going from -2 to a. So this becomes a limit as a approaches 0 of -1/3 times 1 over a cubed minus 1 over -2 cubed. So anyway, we've done the integral, and now we're going to go ahead and take the limit. So as we take this limit, this is equal to -1/3 times 1 over 0 minus 1 over -8. Now right away, we can just see that this diverges. Right? 1 over 0 is undefined. So if that's undefined, if that diverges, that means, of course, that the whole integral also will diverge. Okay, so that's how you approach this problem. So we know that this area doesn't exist, or is infinite, basically. It doesn't matter, it just doesn't exist. So that's how you do these problems. And again, anytime you have a fraction in any definite integral, always do a quick check to see, okay, where does that bottom equal 0? Does that happen between the bounds? If I integrate this from like 1 to 5, there's no problem because it's undefined at 0. But if I'm integrating it from -1 to 5 or -5 to 5 or 0 is in the middle, we got a problem. And I want to give you kind of a warning for what happens if you just blow past this. So let's say you're a chump in the other period. Here's how a chump in the other period would approach this problem. So this chump would say, okay, if I were integrating -2 to 2 of 1 over x to the 4, well, her, I can do that integral. That's just -1/3 x to the -3, going from -2 to 2. So that's just -1/3 times 1 over 2 cubed minus 1 over -2 cubed. Well, her, okay. So that's going to be -1/3. That's 1/8 plus 1/8. So that's 2/8 or a quarter. So you get -1/12. Okay, but if, like, this is obviously a wrong answer. Because if you were to look at this, like, the area of 1 over x to the 4, 1 over x to the 4 makes something like that. Like, if you look from negative 2 to 2, I think that even that chump would recognize, like, that area is clearly not negative 1/2. It's always positive. So you just get these answers that are totally balderdash. This is just completely wrong. So that's why you have to always be aware that you're right as a limit and split this up. Because if you don't, you get this answer that is just wrong and really doesn't actually help us in any way. So always be aware. Check see if it's 0 at the bound or in between. Okay, thanks for watching, guys. Bring the questions to class. I'll see you soon.